Okay, this is a problem which came in the board exams in the year 2020. So let us read out the question. A closed loop is held stationary in the magnetic field between the north pole and south pole of a permanent magnet held fixed. Can we hope to generate current in the loop by using strong magnet? And the second question says a closed loop move normal to the electric field between the plates of a large capacitor. Is current induced in the loop when it is wholly inside the capacitor? Number two, partially outside the plates of the capacitor. It is being given that the electric field is normal to the plane of the loop. Okay, so you can take a screenshot of this question because I'm recording this lecture with my mobile phone, so I hope the picture may not be clear. So just take a screenshot and then you can zoom to read properly about the question. Okay, so let me answer first this question number A. So in this question number A, it is like this. A closed loop is held stationary in a magnetic field between north and south pole. Okay, so this is, let's say, north pole and this is the south pole. And I have a closed loop like this. And this closed loop, it is held stationary in this magnetic field. Okay, so can we hope to generate current in the loop using a strong magnet? Okay, what will be your answer? So the answer is because this loop, it is held stationary. Okay, so when you did not move, right? When the loop is not moving here, it means the magnetic field lines which are crossing from north pole to south pole, these magnetic field lines will remain constant. So as a result, there will be no change of magnetic flux. Okay. Now, even when you replace these two magnets, North Pole and South Pole, with a very strong one, then the same thing will happen because the loop it is held stationary, which means the magnetic field lines will always remain constant and there will be no change of magnetic flux. So the answer in this case, right, we cannot generate a current in the loop by using a strong magnet because strong magnet can only produce a large magnetic field, but these magnetic fields now will not be changing because the loop is held stationary in this case. Right. Okay, look at the second question. Question number B says that a closed conducting loop move normal to the electric field between the plates of the capacitor. Okay, so these are the plates of the capacitor in which one plate is positive and the other is negative. So these are the electric field lines which are generated from positive to negative plates. Now what I have is I have a closed conducting loop and I move it normally in this way. So this is my closed conducting loop and I move it normally in this way, which is perpendicular to the electric field. So the question is the current induced in the loop when the loop is wholly inside the capacitor or when it is partially outside the plates of the capacitor? The electric field is normal to the plane of the loop, which means if these are the electric field, then this would be, if this is the electric field, this would be the loop. Okay, so the answer is current here cannot be induced. Why? Because electric current, it is induced in the loop only when it is passing through a magnetic field, but not in an electric field. Okay, so in both cases, that means in the first case, even when the loop is wholly inside, or in the second case, when the loop is partially outside, no current is induced at all, because current can only be induced when the loop it is passing through a changing magnetic field. Alright, so that is the answer for these two questions. Okay, let us continue with this new problem. So this problem also has been asked in the board exams. I don't know exactly the year, but it has come right before. So the question says, predict the polarity of the capacitors in the situation as shown in this figure. Okay, so this is my figure. So looking at this figure, I have to tell this capacitor A, it is a positive or a negative plate, and this B is positive or negative, like that we have to tell. Okay, so look from this side. Okay, this is a loop. So this is the north pole. So when I move the loop, when I move the magnet, see this directions of the arrow means you are moving the magnets towards the loop. So when you move the north pole of the magnet towards the loop, then this face of the loop, when you look from here, it will behave like a north pole. So that means like this. So if it is like this, then the current will flow in anti-clockwise direction. So looking from this side, you will find the current is going in this way. Okay, but when you look from that side, okay, we have a south pole. So this south pole is coming towards the face of the loop. So this face of the loop, right, in accordance with Lenz's law, that face, when you look from that side, it will appear as south pole. So if it is south pole, it means like this. So the current will flow in clockwise direction. Alright, so looking from here, the current is going in anti-clockwise, but when you look from there, the current is flowing in clockwise direction. So which means, right, when you look from this side, then this current is going in this way. So therefore, I can say that, because we know current is always, starts from the positive plate and goes to the negative plate. So this plate A will be positive and plate B will be negative. Okay, so this is how we predict about the polarity of a capacitor in this figure.